graduated from Harvard Law and the Starfleet Academy. That's where Star Trek is filmed. There's the Starfleet Academy season. You got to watch the season episode. And both. And then also Young Mother.
It's interesting to watch somebody supposed to be filming.
They did, like, half of it, you can tell it's filming. And some of them, yeah.
Okay, let's see if I can get through the rest of this without confusing myself.
Or confusing us in the process, right?
You guys are such humor, right? You're all
That article was so, it was interesting, it was very complex. I mean, you couldn't sit there and read all, you could get the conceptual drift of what he's trying to do. But he really thought a lot.
The Shelley paper?
Yeah.
You have to come up with like an intelligent way to represent it.
More about how he kind of thought about this. But that paper you have, the essential paper, is the original methodology paper for this lifespan methodology piece. And then, as I recall, he kind of goes off into more of an analysis of variance design. And the math has gotten a lot more complicated with the essential sort of separation stuff. And it is Warner's invention, and he did this stuff out of his dissertation stuff. And he's still working with that sample. Insurance panel from Seattle. It's the Seattle longitudinal studies. So in general, sequential analyses basically combine cross-sectional and longitudinal designs. And depending on the design and the analysis, you can probably separate out any two of the three influences. You can't do all three in any one analysis because any two of them totally determines the other one. If you know two, simple math to figure out the other. So you can't separate all of them. And some people that study and think and argue about these things would argue that any one of the designs only gives you a really pure estimate of one of the three, and that the other two are confounded in those designs. A list of those and one of the other things I'll be showing. But at least it gives you a shot of figuring this out. But of course, because it's combining longitudinal designs are already expensive and time-consuming. Not something you want to do. You don't want to start one for your dissertation and make the results. Your time for the PhD would run out before the study did. Complex, and therefore they're kind of expensive to run. But probably really the best way to approach most of these questions. And so, these are your three basic building blocks here. So in this, you've got time of measurement is on the top. So you started your study in 2000, and you're going to go back to people every 10 years. And so you've got a 1950 cohort, and a 1960, and a 1970, and a 1980 cohort. And then so your cells here represent the age that people are at. And so what this gives you is that you can, if you're interested in cohort effects, you can look at cohort effects across ages by going across the columns. Right? If you're interested in time of measurement effects, you can compare times of measurement by going across the rows. You can get time of measurement effects by going down the columns. And then if you're interested in true age effects, you go across the diagonals. Right? And so in all cases, you're sort of averaging out the other influences. Because here, instead of like you're having age, if you're doing a cross-sectional design, and you're just doing one of these columns, you'd be comparing your ages across people from different cohorts. By doing this, you're averaging across time and cohorts, so you get more of some sense, a pure measure of age. Same thing, what you're interested in is cohort effects. You just go the other way. So now you're looking at people from this cohort, but you look at them at several ages. So it's not confounded with age. And you're comparing them to this cohort average across several ages. Something that way.
So the three things are time of measurement, cohort, and age?
Yep. So this just shows you cross-sectional design. This is what I was just doing with the light. This here highlighted longitudinal designs, sequential designs. So you have at least two for each thing. Come back to this in a little bit. So these are the kind of results that you might get figure-wise. You know, for the purposes of this class anyway, you get into this in your own research, you'd have to know how to do the different kinds of sequential analyses. For our purposes, you don't really need to have these clearly separated out in terms of how you get there. But first example here with the cohort sequential analysis, he said that you would be able to do both age and cohort effects, but not time effects. And so you have your 1910 cohort, being a little bit later born, is higher at all points on IQ than the earlier born cohort. But in fact here, you must be thinking of something like vocabulary or accumulated knowledge. Your 70-year-olds are higher on IQ than your 60-year-olds. So you have both an advantage for later born cohorts and an advantage for older age with separate results. I bet everybody's nodding without. I should have told you that. You'll keep on nodding. So, this depending on what data you got. First, they certainly is possible. So cross-sequential analyses, here you're looking at cohort and time of measurement. And so they're thinking here that with sexual attitudes rather than IQ as your dependent measure. And on some basis or another, it's saying conservative to liberal sexual attitudes. And so they're thinking, okay, you get the sexual revolution, the 60s, maybe going on into the 70s. So as a time of measurement effect, you might be expecting everybody's attitudes to have gotten more liberal as a result of the sexual revolution, but they're saying there's an interaction with cohort effects. So the 1940 cohort is actually, there's also a strong cohort effect because the later born cohort was at the beginning and then is afterwards more liberal than the earlier born cohort. But you're also getting an interaction with time of measurement so that the two cohorts actually respond to the sexual revolution stuff in different directions. The earlier born cohort gets more conservative, slightly, and the later born cohort gets more liberal. I don't know if this is true in more than one study. It's at least an interesting sort of phenomenon. And then finally, as a different kind of sequential result, you get time sequential analysis, still sexual attitudes, same time frame. Here, though, what you're looking at is 20-year-olds and 50-year-olds, people who are, in this case, this means people who are 50 here and people who are 50 here. And people who are 20 here and people who are 20 here, right? So they're not, it's not aging over time. It's you actually got different cohorts, so you're keeping the age the same in times of measurement. So and you've got your younger people then at both times are thought to be more liberal in their sexual attitudes. Later points in time, I don't think this would be true. That's another story. But you've got